Okay, this is part 2 of the 3.5 video. We're starting with example 3. That's where we left off on the last video. This is nothing different than what we did in class, except now we're not actually going to graph anything because we don't even know what the parent function is. It's just being called f. What we're just doing is describing the transformations that we see. So notice that in this one, there's 2 transformations. I'm going to outline them here, and then we're going to write them in the correct order that they would be performed. This has got something happening inside this function. When it happens inside, it affects x. If it's a plus or minus, remember it's something to do with either right or left. We always do opposite to what we see. So this would be right 1. When you have a number in front of your function, it has to do with either stretching or compressing in the y direction. So this is a 3, and if you're greater than 1, you're stretching. If you are less than 1, or between 0 and 1 is how we think of it, you are compressing. So this would be a stretch by a factor of 3 in the y direction. Now, you always write the one that is closest to the original x as your first transformation. So this would be, to transform this, we would go, the function should be moved right 1, and then stretched by a factor of 3 in the y direction. Now there's other ways you could say this, but this kind of defines it out as a sentence. Okay, so looking at B, notice again there's something happening inside, and it's a plus or minus. That means it has to do with shifting right or left. So it's always opposite to what we see inside, so this will be left 4. A negative out front, remember, is a reflection. If it's out front, it reflects over the x-axis. If it's inside, it reflects over the y-axis. And what we mean by a negative being inside is being connected it actually to the x term. A negative like this is really not a negative inside, so the negative would have to be attached to that x. But for us, the negative is out front, so that's going to be a reflect over the x-axis. If it was inside attached to the x, it would be over the y-axis. Again, this one's closer to the x, so it goes first in our listing. So the function should be moved left 4 and then reflected over the x-axis. Okay, and then our final one here, we have a number inside that is connected to x. That's not a left or right move. This is either a stretch or compression. It's always opposite what you see when it's inside. So even though that's a fraction, that normally means compression in our mind when we're outside. So this time it's actually a stretch because it's opposite of what we see. And it's opposite of the actual number too. You do the reciprocal. So it's a stretch of 2 in the x direction. Okay, and then when you have a number added or subtracted at the end, remember that's a vertical shift, and this would be down 3 because it's exactly what you see. So our sentence would be the function should be, oh, by the way, the one that's inside is first because you always do the one closest to x first. The function should be stretched a factor of 2 in the x direction and shifted down 3. So notice this is just telling someone what the transformations are in words. So that's what this was about. Okay, our final example that we're going to do on the video, it has multiple parts, but it's all the same kind of things. It's again just shifting a picture that was given to you using given transformations. I'm going to write the 5 key points that are important for this graph, and we're going to use those to help us do all the transformations. And then what's going to be left after this is just 2 piecewise functions that we need to actually define in class and do together. Then we'll cover that and 3.6 on our next class session. We're going to have to shift our test back one date. That's just unavoidable at this point. We'll do 3.7 on the next class, and then the next week we'll review and then test. We'll have to play catch up when we get to Unit 3, which will be easier because there's some shorter sections. I don't want to rush you on anything in Unit 2 since some of it's actually a little more complex than some of the things we're going to do in Unit 3. So for example 4, we've got this graph right here. It is 0, 0, because I want to know my 5 key points that I can see here. 1, 2, 2, 0, because that's at the x-axis again, 3, negative 2, and 4, 0. I'm going to take these 5 key points and look at these directions for how to transform them. So again, we're just trying to look at this. We don't really know what this function's name is. I don't know if it's like, it looks like a sine wave, essentially part of a sine wave, but we wouldn't know that just by looking at the picture. So they're just telling us to transform these 5 points. And you can do transformations on a point-by-point basis. So I'm going to write my 5 points, 0, 0, 1, 2, 2, 0, 3, negative 2, and 4, 0. This is an inside plus or minus. Remember, that means we're doing a horizontal shift. This means we're going right 2. Another way of thinking of that is going plus 2 to all the x's. You're undoing what they did essentially. So if we add 2 to all of our x's, that would make the y's not change at all. So notice the first thing I'm doing is just copying all these with the same y's. But these all increase by 2. So this would now be 2, 1 plus 2 is 3, 2 plus 2 is 4, 3 plus 2 is 5, 4 plus 2 is 6. If we plot these 5 new points, you'll notice that it took that same exact graph and just shifted it right 2. Now my graphs are obviously a little tinier, mainly because my scale was a little tinier on the pre-made graphs that I had. But it's not been shrunk or anything, it's just we've zoomed out a little bit. So notice it's been shifted right 2. So notice this case would then be shifting it left 2. So I don't feel like I need to do a point-by-point analysis for this one since it's the same graph and it's the same type of transformation, just left. So 0, 0 would go to negative 2, 0. 1, 2 would go to negative 1, 2. 2, 0 will end up at 0, 0. 3, negative 2 ends up at 1, negative 2. And 4, 0 ends up at 2, 0. So this is just going, everything is left 2 from the original picture. So just imagine taking those and moving each one left 2. You could do the point-by-point analysis, but it's the same type of deal as the first one. Okay, so this one is taking those 5 points, sorry, it's not wanting to center, and we're doing something outside of the function. So this means we're moving with a vertical shift, so that's down 2. So remember, down 2 means that we subtract 2 from the y's. You do exactly what you see. So my points were 0, 0, 1, 2, 2, 0, 3, negative 2, and 4, 0. Those are my original points. If you subtract 2 from each of the y's, notice this time the y's are going to be the thing that changes, so the x's are staying the same. So I'm going to just copy all of my x's over. 0, 1, 2, 3, and 4. But we're going down on all the y's, so that would be negative 2, negative 4, negative 2, negative 4, or excuse me, this one would not have been negative 4 up here. 2 minus 2 is 0, sorry. And then 0 minus 2 again is negative 2. So I just subtracted 2 from each of those y values. So 0, negative 2, 1, 0, 2, negative 2, 3, negative 4, and 4, negative 2. Notice my same original graph just got shifted down 2. So when we do this next one, it's the same kind of problem except we're just going up 2 or adding 2 to the y's. So this would be 0, 0 would move up to 0, 2. 1, 2 would move up to 1, 4. 2, 0 would move up to 2, 2. 3, negative 2 would move up to 3, 0. And 4, 0 would move up to 4, 2. So notice same thing. The whole same picture, just shifted up 2. And you could do it point by point if you need to as well. Here's where things are going to get a little bit more interesting. So I'm going to have to do more of my point listing here. So I'm going to list my 5 original points. 0, 0, 1, 2, 2, 0, 3, negative 2, and 4, 0. There are actually 2 transformations here. The 2 is greater than 1, which means we're going to have a stretch because it's outside of the function. There's also a negative sign out front, which means we're going to have a reflection over the x-axis. Now, I usually do the number first and then do the reflection. So having a 2, a stretch, means that all my y's need to be times by 2. So that would still be 0, 0. This one, though, would be 1, 4. This would be still 0. This would be 3, negative 4. And this would still be 0. So I times all of my y's by 2. What that does is stretches them out. Then I need to reflect, which means all of my y's are going to change signs. Okay? So that means 0, 0 is still going to be 0, 0. A 0 cannot change sign. This would, though, be 1, negative 4. This would still be a 0 for y. This, though, would be a positive 4. And this would still be a 0. So notice, both of these reflections only affected the y values because they were outside of the f of x. So these right here, these 5 are my final answer. I've done all of my transformations. So 0, 0, 1, negative 4, 2, 0, 3, 4, and then 4, 0. Notice that I still have the same graph shape, but it has been flipped upside down and it's stretched out along the y-axis. Okay, we have just a few more to go, just making sure we do some different types of transformations. So this one is, I'm going to show all of my points on all of these that have numbers and negatives. This one is got a reflection outside again over the x-axis, which means your y's are going to change signs, but it has a compression this time because it's a number in front that is between 0 and 1 without considering the negative part. So then what we do is we take our 5 points, so we're going to write those out again. Oh, 1, 2, sorry. 2, 0, 3, negative 2. This was all from that original graph that they gave us, and 4, 0. I usually do the compression first and then do the reflection. So this would be, we're going to half all of the y's, because when it's outside you do exactly what you see and you do it to the y value. So 0 half is still 0. Half of 2, though, is 1. Half of 0 is still 0. Half of negative 2, though, is negative 1. And half of 0 is still 0. Okay, and then we're going to reflect, which means all the y's are going to change their signs. So 0 would still be 0. But this would now be a negative 1 on the y value. This would still be 0. This one changes to a positive 1. And this one is still 0. 0, 0, 1, negative 1, 2, 0, 3, 1, 4, 0. Notice my shape is upside down again, and it's much more compacted. It's been compressed on the y-axis direction. Okay, this one has a negative inside and it has a 2, so we have 2 things going on inside. When a negative is inside in front of the x, it's a reflect over the y-axis. When a number is inside, it's opposite of what you would see. So this would normally be a stretch because it's greater than 1, but if you're greater than 1 and you're inside, you're a compress on the x-axis, and you do the opposite of what we see. So we're going to take half of our x's. So our 5 points, 0, 0, 1, 2, 2, 0, 3, negative 2, and 4, 0. I usually do the number first, then the reflection if they're both side by side like that. So I'm going to take half of all my x's. Half of 0 would still be 0. Half of 1, though, is a half. Half of 2 is a 1. Half of 3 is 3 halves. Half of 4 is 2. Notice this was to the x's. Then I'm going to change the signs of my x's because I'm doing a reflection over the y-axis, which means the x's change signs. 0 would still be 0. This would be negative a half and then 2. Negative 1 and then 0. Negative 3 halves, negative 2 still, and negative 2, 0. Notice the x's are what change signs when it's inside. So this would be plotted out as 0, 0, negative 1 half, 2, negative 1, 0, negative 3 halves, so that's 1.5, negative 2, and negative 2, 0. So notice my shape has been reflected across and squished in or compressed. And then we have this one right here before we get into some multiple transformation ones. This is just got the 1/2 inside. Oh, give Word a second. It doesn't want to cooperate. Okay, so on this one we have, it's still not wanting to cooperate. Okay, we have a 1/2 inside but no negative this time. So this is going to be opposite of what we think. So it's going to be double all the x's. So 2 times all of my x's, which means it's actually going to be a stretch on the x-axis or x direction. So then I take my 5 points that we've been doing for each of these because it's that same shape they gave us in the directions. And in this scenario, we are doubling all the x's, so 2 times each x. That would still be 0, 0. This would be 2, 2. This would be 4, 0, 6, negative 2, and 8, 0. So you notice this will stretch out that graph on the x direction. 2, 2, 4, 0, 6, negative 2, and 8, 0. So it's a much wider stretch to get to the end. All right, now let's talk briefly about some multiple transformation ones for the same graph essentially. For this one, we need to go left 4 because of this inside here. So remember that's subtracting 4 from each x. If you want, a better way to write that is to write, I don't want a highlighter, x minus 4 essentially. Each x needs to have 4 subtracted from it. We also have a negative at the end, so that means we have a down 2, which means each y needs to have 2 subtracted. But we also have a reflect across the x-axis, which means my y's are going to change signs. Now, you have to do these in order. This closest to x, next closest to x, farthest away. So 1, 2, 3. So we're going to take our 5 points. I'm going to list them out. And we're going to do each transformation one at a time. So 0, 0, 1, 2, 2, 0, 3, negative 2, and 4, 0. I do the left 4 first, so that means each x is going to have 4 subtracted from it. So this would be negative 4, 0, negative 3, 2, negative 2, 0, negative 1, negative 2, and then 0, 0. So I subtracted 4 because that's the opposite of what I see right here from each of those x values. Then the next thing would be the reflecting. So the y's are going to change signs. So -4, 0, can't change signs. -3, -2. -2, 0, can't change signs. -1, +2, 0, 0, can't change signs. My final thing is for my y's to lose 2 because it's a down 2 at the end. So that means all of them are going to get smaller by 2. So -4, -2, -3, -4, -2, -2, -1, 0, because 2 minus 2 would be 0, and 0, -2. So let's see where we end up. -4, -2, -3, -4, -2, -2, -1, 0, and 0, -2. This graph got shifted left 4, flipped upside down, and then moved down 2. And then the final one for this video is this transformation right here. Same 5 points. This time we are going to be moving right 4, opposite of what we see inside, which means we're going to be plussing 4 to each of our x's. And then on the end we have a vertical shift, and you do exactly what you see. So we're going to be going up 2, which means we're going to be adding 2 to each of our y's. So then our points were 0, 0, 1, 2, 2, 0, 3, -2, and 4, 0. Remember, these 5 points I'm not making up. They came from that original picture at the very beginning of the directions. So again, do the one closest to your x first. So this would be, we're going to do 4 added to each of those x's. So that'd be 4, 0, 5, 2, 6, 0, 7, -2, and 8, 0. Then we're going to add 2 to each of the y's. So that'd be 4, 2, 5, 4, 6, 2, 7, 0, and 8, 2. So 4, 2, 5, 4, 6, 2, 7, 0, 8, 2. So notice the same size as the original, but shifted right 4 and then up 2. Now, did you have to do each of these point by point? Not on all of them, but sometimes just listing out the directions and writing the point by point changes does help, especially when there's multiple transformations going on. So that is the end of what we're going to do on the videos. Like I said, there's one last piece to 3.5, but I want to talk about it in class together, and then we'll jump right into 3.6 after that. Again, the test, the review, and the quiz, everything has been shifted 1 day off of the original calendar, and we will play catch up in Unit 3. I'm going to try to combine a couple of the days, have just 1 section per day, and I think we can get 1.5 in on a couple of those, so that'll get us caught back up. All right, have a great rest of your spring break.